Hello there, this is video number 9, and this is chapter 7, section 3. And this is about double angles, half angle, and reduction formulas. All right, so what I'm going to do is give you, there's 3 for each of these, 3 double angle formulas, 3 power reducing formulas, and 3 half angle formulas, and then do some examples for each of them. Also, I already have prepared my unit circle. You are definitely going to need that. So you may want to have that accessible to you somewhere because we are going to be utilizing that quite a bit to solve some of these. So, all right, first thing we're going to do is list some of these guys. So let's do our double angle formulas first. All right. And that's going to look like sine, and in parentheses, you're going to have 2 theta. Remember that theta just represents an angle, and that is 2 sine theta, cosine theta. And then you have cosine of 2 theta, and there's actually 3 of these. So depending on the information you're given, you're going to want to pick the one that suits you best. So this is cosine squared theta minus sine squared theta. Looks like your Pythagorean identity. And then you have 1 minus 2 sine squared theta. And then 2 cosine squared theta minus 1. All right, so you could use any of those 3 if you see cosine of 2 theta. And then we have tangent of 2 theta. And that is equal to 2 tangent theta over 1 minus tangent squared theta. Okay, so that's your list of double angle formulas. And like I said, I'm going to give you all the formulas, and then we'll talk about how to use them. So next, and I just have these on a single sheet and then referred to those. So I'm going to go to a different screen, but you should be able to fit all of these on one sheet of paper. All right, so next, I'll do these guys in blue, the power reduction formulas. Okay, and that's a colon. Didn't really work. My pen didn't pick all the way up. So we have sine squared theta. So if you see sine squared, you could write that as 1 minus cosine of 2 theta, which is interesting because now you could plop in one of the double angle formulas from above, over 2. Cosine squared theta is 1 plus cosine of 2 theta over 2, and tangent squared theta is 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Okay, so there's your 3 power reduction formulas. Let's see how we can utilize those. And then the last ones are your half angle formulas. I don't know why that's doing that. Sometimes this software is a little funny. All right, so sine and cosine have 1 each of their own, and then tangent actually has 3 for this one. So we have sine of theta over 2, and that equals plus or minus the root of 1 minus cosine theta over 2, and make sure your root extends all the way over the entire thing. Cosine of theta over 2 is plus or minus the root of 1 plus cosine of theta over 2. And then tangent of theta over 2 has 3 of these. And they look like plus or minus the root of 1 minus cosine of theta over 1 plus the cosine of theta. And then the middle one is sine of theta, no root, over 1 plus cosine theta. And the bottom one is 1 minus cosine theta over sine of theta. Okay, so those are the angle formulas for that. Remember that this is 7.3. All right, so I'm going to give you some varsity examples and then some textbook examples, and we'll go from there. So here's how we're going to utilize these. You're going to get an example that says something like, let cosine of A equal 3 over radical 13 with A, and so that means A is an angle, right? So that could be theta, in quadrant 4, comma, find cotangent of 2A. All right, so there's a couple of things here. First off, note that I gave you, well, here, cotangent of 2A. The 2A indicates, of those formulas that I gave you formulas for double angles, half angles, and reduction formulas. So you need to determine which one of those that is. And the 2A's, all of the 2A's, or 2 thetas, are double angle formulas. However, I only gave you formulas for sine, cosine, and tangent, right? I didn't give you one for cotangent, which is why I picked this problem. But we know that cotangent is the reciprocal of tangent. And so what we're going to do is we are going to find, oops, geez, I can't spell. It's actually kind of early in the morning. It's not. It's 10:38 when I'm doing this. But apparently it's too early for me to spell. I've only had 1 cup of coffee. We are going to find the tangent of 2A and then flip the result to get the cotangent of 2A. Okay, so we're going to find tangent, and if we flip it, we get cotangent. All right, so we also have some super useful information here. We know that we're in quadrant 4, so I'm going to draw a picture, because if you don't know this about me yet, I like pictures when I'm doing math. And we need a triangle in quadrant 4. So remember, that always drops down from the origin and connects to the x-axis. Our theta is always in here. And then we're told that the cosine, this is also super important, is 3 over rad 13. Well, remember, cosine is adjacent over hypotenuse. So 3 and rad 13. All right, so I'm going to go back and take a peek at my formula for my my tangent of 2 theta, just to see what I need. Tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So in order for me to find tangent of theta, I need opposite over adjacent, which means I need this side right here. And so we can do that using Pythagorean theorem. So we'll go 3 squared plus x squared. Technically, I guess that's y squared. If we want to be absolutely accurate, why don't we do that? Math is all about accuracy, right? So let's be accurate. That's our y squared side, equals the root of 13 squared. So 3 squared is 9 plus y squared equals 13, right? Because rad 13 times rad 13 gives you just plain 13. Subtract off a 9. So y squared equals 4. So y is going to equal 2. And remember, you're taking the root. Those cancel. Take the root. So this side is going to be a 2 when we actually solve that. And also keep in mind, we know that this is in a negative direction. So this is a -2 when you fill that in, right? So now we're just going to take this information and fill in this formula. So 2 tangent theta. All right, so I have 2 tangent theta. So I'll rewrite the formula down here. I like to see what I'm doing. So I'm going to do that in black. So tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta. And if you want to somewhere, you can write for yourself tangent of theta. We know it's opposite over adjacent. I have that over here, right? So opposite is -2, adjacent is 3. So tangent of theta is -2/3. So now if I fill things in here, I keep the 2. Tangent of theta is -2/3. And that's going to be over 1 minus tangent of theta is -2/3. And I'm going to square that. Okay. Now I'm just going to do some math and simplify. So this is over 1. So this is going to be -4/3. I'm going to square this guy here. This is going to be 4/9. So I have 1 minus 4/9. Well, the 1 is going to turn into 9/9. So 9/9 minus 4/9 is 5/9. And remember the whole keep, change, flip thing, right? Because this is really -4/3 divided by 5/9 to make this go away. And then I would keep the first one, change the division to multiply, flip the second one upside down, and then I can do some cross canceling. I know that the 3 will cancel into the 9 3 times, and then 4 and the 5 won't do any canceling. So this is going to be -12/5. And so the tangent of 2 theta equals -12/5. Okay, and so that's what you're doing with these. You're actually going through and figuring out what those are going to be. I'm looking at my paper and I have 5/-12. I made a boo-boo somewhere and I have to find. Nope, it's in my work on my paper, not in my work with you. So we're good. All right, so that's all that you're doing is utilizing that information, plugging it in, simplifying, and going from there. All right, next example. This one is going to use our unit circle, just an FYI if you need to get that out for yourself. Okay, so this one says simplify 2 sine 105 cosine 105. And that's all it says. That's all the information that you get. And so what the hint that I'm going to give you is to match the format given here to a formula that you have given earlier. Okay, and if you take a look at those formulas that I gave you, you will see that, here's what I'm talking about. If you go back and look, I'm going to just flip back through these. I'm going to go back to the beginning. We have this formula right here is a 2 out in front, and then a sine of theta and a cosine theta, which is exactly what we have. I'm going to flip back to this page we're on. 2 sine of an angle, cosine of an angle, and it's exactly the same angle, right? So 2 sine theta, cosine theta, that's exactly what that is there, equals sine of 2 theta, right? That's that entire formula. So what we're going to do is we're going to plug, we know theta equals 105 from the problem, right? Let me highlight here. This is kind of going backwards and pulling stuff out. We know our theta is 105 for that to be true. And so what we can do now is we're going to go a little bit backwards. And what we're going to do is we're going to say the sine of 2 times 105. Well, that means we're looking for the sine of 210. And if you look at your unit circle, we're going to find the sine of 210. And remember, all of the ordered pairs are cosine sine. Okay, so I'm going to flip back to my first screen, and we're going to go to the unit circle. We're going to go to 210 degrees, and we're going to find the y-coordinate, okay? So I'm going to go to my unit circle, go to 210 degrees, find the y-coordinate. So the sine of 210 is negative 1/2. And so the sine of 210 is equal to, I'm going to change pen color just so it stands out. This is equal to negative 1/2. And that would be the answer to that question. All right. So you're just using your unit circle. You're unpacking the formula, so to speak, to get some information there. All right. Let's do another one. Let's see. If cosine of A is 1/2 with A in quadrant 4. So this is similar to the first problem. Then find cosecant of A over 2. Okay, so again, you need to determine if this is a double angle, half angle, or a reduction formula. So let's go take a look at those real quick. I have double angles here on this screen, and that doesn't fit the formula of the double angle, right? Because what we're looking at is in here. We have A over 2 in our problem, and these are 2 thetas. So that doesn't fit the right form. Let's look at the next screen where my next set is. So these are all sine squareds. So that, again, doesn't fit the formula. And these guys are an angle over 2. So we are looking at a half angle formula for this problem. And again, if you recall the problem, well, you could see it on your paper. We're looking for the cosecant, which is the inverse of sine or the reciprocal of sine, right? So what we're going to do is find the sine and then flip it, and we'll have cosecant. Okay, so I'm going to utilize this formula right here, 1 minus the root of 1 minus cosine over 2. So let's take that back to our other screen. So we have the sine of theta over 2 was plus or minus the root of 1 minus cosine of theta, or A in this case, over 2, right? That was the right one. Let me just double check. 1 minus cosine over 2. Okay, because you know sines can make a big difference, right? So what we're going to do is we're going to take and we're going to draw our angle in quadrant 4. Here's my angle. Here's my triangle. We know cosine is a half, so 1, 2. We need to know this side here. And we especially need to know that if we want sine of theta, we need opposite over hypotenuse, right? So we need to know opposite. So let's find out what that is so we can fill in what the sine is. So we have 1 squared plus y squared equals 2 squared. So that's 1 plus y squared equals 4. Subtract a 1, subtract a 1. Y squared equals 3. So y equals the root of 3. And remember that this is going to be negative here. Okay, so sine is going to be negative rad 3 over 2. Now, listen, I'm going to tell you, you could have, if you had realized cosine in quadrant 4 is positive, right? And it is also, cosine is a half at 60 degrees, which means at 300 degrees on your unit circle, this is a true statement, right? I'm going to flip back to the unit circle here real fast, just so you can see. You could have saved yourself all of this work. I want you to think smarter, not harder, if you can. Some of you might be able to think about these things this way. So I just want to point out that this work wasn't really necessary if you truly know your unit circle. So this happens, I'm pretty sure it's at 300. I'm almost positive. So if we know that that happens at 300, that's our x coordinate. The y coordinate should be this guy, right? So let's go take a look. So 300 degrees, if x is a half, y should be negative rad 3 over 2. Okay, so here's what we're looking at. X is a half, y is negative rad 3 over 2. So if you recognize something off of your unit circle, cosine is a half, you know from the first chapter that that actually happens somewhere. Do you need to do all of that work with the Pythagorean theorem? No. But if you don't recognize it, you can do that work. And if you're accurate, it's no biggie. It's going to come out the same, right? But you could save yourself that work if you do have that recollection that, hey, that's a value on my unit circle. I know that. I've seen that before. Cosine really is a half. Let me see if I can find it. And just go look. And you can just know that sine is negative rad 3 over 2. Okay, so let's plug this stuff in here. Oh geez, now I'm the dumb one. Take a look at this. In this formula, I don't even need sine. I only need cosine. So I did all that work for absolutely no reason. Oh, think smarter, not harder, Miss Christie. All right, so here's the deal. We're going to plug in plus or minus the root 1 minus cosine of theta is a half. We know that. Over 2. All right, now you got to do some math here. So the 1 turns into 2 over 2. 2 halves minus 1 half is 1 half. So I have 1 half over 2. Well, now I can do a keep, change, flip. That's that. And then multiply by that. And this is gone. So if you multiply this guy, you get the root of 1/4. And the root of 1/4 is equal to 1 half. And so the sine, sine, let's just scribble that out. Sine of theta over 2 is 1 half. And then remember that what we were trying to find was actually cosecant, right? So we need to take and flip this guy upside down. So cosecant. And keep in mind, we're in quadrant 4. So in quadrant 4, sine is negative, which means cosecant is also negative. And that would be your answer to that guy. All right, let's see what else we've got here. A couple more examples to make sure we can successfully do all of our varsity. All right, next one, new page. Example, if sine of A equals negative 3/5 plus A, and A, that's an and A, I'll write that out, and A is in quadrant 4. Oh, why are all these in quadrant 4? That's weird. You realize that's not always going to happen, right? Then cosine A over 2 equals, and you're supposed to find cosine of A over 2. Now, this guy, not on the unit circle. Right? So in this case, we're definitely going to have to set up our triangle. So we're in quadrant 4. Let's make sure we actually need to find this, though, before we do anything. We know sine, here's our angle. Sine is -3/5. And for cosine of A over 2, let me go back and look at my formula here. Cosine is plus or minus the root of 1 plus cosine theta over 2. So we do need cosine, so we do need to find this missing side here. Have you done enough of these to know if you have a 3 and a 5 that the missing side is a 4? That's a thing. That's a 3, 4, 5 triangle where your hypotenuse is always the longest side, right? You could solve this out, Pythagorean theorem, and find that for sure. But a 3, 4, 5 is what's called a perfect triangle, and they use those a lot in trig. So you can shortcut that if you recognize that that's happening. Feel free to do Pythagorean theorem on your own and prove that if you want, but it's not necessary and you can save yourself a lot of time. So if we know that that's a 4, then we know that the cosine of theta is 4/5, and we can now use that in our formula over here. So cosine of A over 2 is plus or minus 1 plus 4/5 over 2. All right, well, the 1 is going to become a 5/5. And so now I have a 9/5 over 2 over 1. And really, I should be very specific here. That root should be over the entire thing. And then I'm going to do a keep change flip. So this will become a 1/2. This is gone. Multiply across. I get 9/10. Remember, this is a plus or minus in front of there. This now becomes the root of the top and the root of the bottom. The root of 9 is 3. And I don't know if you need to actually rationalize that in varsity. If you do, however, remember that you're just multiplying by rad 10 and rad 10. So you'd have plus or minus 3 radical 10 over 10. If I was giving you a paper test, I would expect you to do that. I'm not sure if you need to do that in varsity, so you could try it and see if it gives it to you. If not, make sure you rationalize. All right? So the math there, not terrifically difficult. All right, the last one. Let's see if we can do this. This one utilizes some things that you did in the last section, I think. I need a new page. And then we're going to go, all right, if sine of A is 4/5 with A in quadrant 2, and B, and sine of B, that word's important, equals -3/5 with B in quadrant 4, find the sine of A plus B. All right, well, this guy was back to sum and differences in 7.2. So you would need the formula for sine of A plus B, which was sine of A cosine of B plus cosine of A and sine of B. All right, and then what we need is I'm going to draw 2 separate triangles, one for A, one for B, and we need to find everything we need. So we'll do this. We'll make this for A, and I'll do this one for B. So we have sine of A is in quadrant 2. So we're going to put, quadrant 2 over here. Our theta's here. We know sine is 4/5. That makes this guy 3 and negative, just to be specific with our signs. And we know we need a sine and cosine of A. So me personally, I like to list these underneath. And we know sine is 4/5, but cosine is negative 3/5, right? And that's coming straight off of that information that you have there. All right, and then for B, we're in quadrant 4 here. So I'm going to draw this guy. Theta's here. Excuse me. Sine is negative 3/5. That makes this guy 4. So we know sine of B is negative 3/5, which means cosine of B is 4/5. And now I can use this information, these two and these two, to expand out into this formula. Okay, so I'm going to do that in green down here underneath these boxes. So sine of A is 4/5 plus B is actually plus B. So plus B is a negative 3/5. Okay, so I'm going sine of A is 4/5. Cosine of B is also 4/5. And then I'm going plus cosine of A. Cosine of A is over here, negative 3/5. And sine of B is also negative 3/5. Now these are getting multiplied, right? So this gives me, I'm going to move my screen down a little bit, 16/25 plus 9/25. And then when you add those together, you get 24/25. And so sine of A plus B is 24/25. Okay. Oh, I'm sorry. I added that wrong. Holy cow. All right. 16 and 9 is not 24. It's 25. My bad. Did any of you catch that? If you did, you should have been like yelling at your screen. Mrs. Christie, that's wrong. And then 25/25 is 1. So that's what you are going to get when you do that. All right. So again, this is 7.3. This wraps up that whole thing. And I believe there's a varsity assignment for 7.3. All of our problem sets are over. This should actually, hopefully, be a nice kind of respite, actually doing some math after doing all of those. What were those things? Oh my gosh, identities. That's what we were doing. So, all right. Well, that's it for now. So, toodaloo.